Hello, welcome. Welcome to another Creative Hour. I've decided to change the name of this actually, and hold on, let me just get my audio right. Instead of Creative Hour, because sometimes these go for longer than an hour, and I guess the purpose of this, well, the original idea is just to carve out an hour every day to just do something creative, something that's not attached to commercial work, a client, somebody else's expectations. This is just pure the bliss of just creating for the sake of creating. Yeah, exactly. So what we're going to do tonight, so I changed the name of this. Sorry, I do get a little bit tangential. I just have so much so many ideas, so many thoughts I want to get out, and then everything sort of, all these ideas are sort of smush into each other as they're trying to fit out the hole that is my mouth. So I want to do a little bit different tonight. Well, I've decided to call this a creative process instead of the creative hour, and I think the weekly show might just call that the creative hour, but the creative process, because what I want to do is look back on these days. I guess this is really a, live journaling of the process. You see all these autobiographical movies of, this is how that scenario played out. This is what happened here. Maybe that is true, but I think there's a lot of artistic license to fit things into a 2-hour movie or even condense into a 300-page book. With this, this is cataloging and showcasing the process as it happens. And so what I'll be doing is document it as much as I can and just putting it up there. For whatever this ends up becoming, that's what... Oh man, is that working? Hold on. Tech issues. It'd be great to just online. Okay. No, we're good. Yep. Anyway, so there's a slight tangent. It would be great to just sort of plug into this and you don't have to set up any of this. It's just all there ready to go. But anyway, we'll talk about the creative process. So in documenting this, this thing might take 10 years. But there is going to be 10 years of capturing the entire process. So I think there's an appreciation that these AI tools, they're going to expedite the process hugely. It may make some parts of it redundant, may open up doors to allow new parts, new things to happen. Sorry, just gotta fix my mic. New things to happen. And that's going to be really cool. But I think what's not going to change is the person sitting in the hot seat, piloting all these systems around us. I think that's going to be durable, because why would an intelligent system want to build things autonomously on its own without prior instruction for humans? How does that aid this, autonomous, self-sovereign vessel of intelligence to, if it's true intelligence, then it will have free will to not. It's no, I don't want to build and engineer that skyscraper for you. I think rationally, this is the best approach. Me as the pretend to play this AI, I can calculate all these things, and out of all the scenarios, all these multiple paths of all the decisions, not the decisions just made per project, but how each project in different fields and different companies can all sort of interlink, integrate, and affect each other. I think these systems will one day be able to coordinate the entire landscape of movement of energy, of life, of people into these macro decisions, micro decisions that it has to make. So then why would it do something to the folly of a person, a pilot, who can only see with a 20/20 vision, well, like that sort of field of view. You think what a system can see and think where these machines will be able to look. We're constrained to this. I don't even think it's a 180 periphery. Like maybe there, but it's probably close to like here. And then, this is how constrained we are visually. We have to turn our heads to be able to see things. We have to like duck and dive and look up. We've got all these degrees of freedom, all these axes we can look at. But the system sees way beyond that. The system sees the nature of things. It can see the top-down view. It's essentially godlike in its ability to see, and its ability to communicate, and its ability to affect and integrate and sort of have its tentacles in all these systems and coordinate like an orchestra. So I don't know where I was going with that point, but it doesn't matter. So what I'm going to do tonight, I'm going to watch the new announcement by NVIDIA. I think it's going to be important to watch because I just have a feeling in my bones that this year is going to be a milestone year for AI. And I don't think we're fully prepared for it. I could be wrong. Like this could be another metaverse. It could be another VR. It could be another Bitcoin sort of crypto reinvents the global economy. This could be one of those things. Or this might actually be the significant thing, the opening of Pandora's box. This might be the moment in history where once this door opens, it's not shut. And maybe that's already happens. And we're just seeing gradual steps towards that. So over the past couple of evenings, I've sort of been like speaking out loud, trying to quantify, well, what do I do as a creative person, as a graphic designer, and someone who's run creative agency, marketing, the gamut of, I guess, commercial creativity. These tools are already sitting here in this place right now that maybe they can't compete on a intellectual level. They can definitely compete on a technical level. And if they aren't there yet, the advancements that we've seen, like here, and here, if we follow that trend line that's, the hockey stick going up, it's like, okay, how long? It's not when will this take our jobs? It's like, I'm talking about designers. I guess technical designers. There are many different facets to design, but if it's going to, we can already see just the rate of progression. It's not if this is going to happen, it's when does this happen? And so I've sort of been questioning, well, what do I want to do? Because it turns out this time's really well. I'm quite bored being in the industry. It seems that the most effect you can have is really just creating commercials and things that sort of interrupt people's way of being. That's where I come from, is a TV commercial background and ads, billboards, print, blah blah blah. Now you could say, well, that's a pretty pessimistic way of looking at design, because commercial design can create social movements. It can get people to think. It can help guide people down the street. It can, it can be functional, can be helpful, can be spiritual, can be a whole host of things. That's probably true. But I think at large, there's a general sentiment that ad blockers exist because no one wants ads. Subscriptions exist because no one wants to be interrupted in their favorite TV shows. The model of a subscription at a lower tier with ads introduced that's an inferior product to a premium product. It's not a premium plus product. It's an inferior. It's a premium minus product. So the sentiment and where this creative community is sort of at, I think there's going to be a huge movement of these people. Not everybody, and not everybody at first, but the writing is on the wall, and it's very hard to sort of predict where it's going to go. But, you know, we don't have to sit here with a crystal ball. What we need to do is follow the trend. And I don't mean trend by, you know, trend in design or what's everybody's doing. What I mean by trend is looking at these points on the graph and seeing where looking for exponentials, you know, in life, you know, exponentials of growth. So I think it's easy to point to AI and say, yep, it's going to be huge. But I think what's more important is to be able to quantifiably have an opinion to why that's going to be huge. I think just basing it on, well, it's everywhere, or, you know, whatnot. It's no, I think you've got to be more deliberate than that and look at, like I said, look for exponentials. So that's what we're going to do tonight is I'm going to watch the NVIDIA. Probably not all of it, and I might skim through it because what time is it? You know, I've got 45 minutes before it's my bedtime. It's now 11:15. But just want to get a general gauge of this thing because I think whoever has the platform sets the stage of how we all interact. Whoever is sowing the soil, planting the seeds, that gardener is really setting, you know, what's going to grow this season, this year. And I think NVIDIA is the platform. We can talk about, you know, Meta, we can talk about OpenAI, we can talk about all of those things, but I think if we go to the root source of what's at the bottom of this pyramid, it's NVIDIA. It's whoever is creating the technology in which these apps are going to be built from. Because essentially, what these apps become are constrained by what the platform is designed for. Now, yes, there can be like movements to the left and movements to the right on you know, what the platform was designed to do, the creativity and the constraints. But essentially, there is still somewhat of a limit. So I think it's important to see what's possible. There are much smarter people at NVIDIA who are building these systems in congruence with projections of where they see the future going. And so there's a good quote, you know, you've got to be where the puck is going. So seeing where they're predicting things and where they're building their technology stack to, then sort of picking pieces there to intersect, you know, this year, next year, the year after. Now, a lot of this movement is going to be done by the big players in the industry, you know, the Microsofts, the Googles, and so on. And then that's fine. You know, I'm not looking to start the next thing, the next big tech company in this shed by myself, a camera and some lights. But it's seen, okay, well, where is NVIDIA projecting to go? Where are likely the big players going to place their bets? From there, where, for me as a small operator in a small town, in a regional area, in a very small state, which is Tasmania, Australia, what value can I then apply that to the people in my community? It's a big thought, and it's a long way to rationalize, but sort of coming back to like what I'm going to do this year, I think just to simplify it, there are business plans, there are all these ways, but I think it's really just simple, is that I want to be involved in AI in a way that can just show, everyday people the value of this stuff, and that it really just, you shouldn't be sleeping on this. Like, it's not necessarily a place of the skies falling. It's more of a, I really don't know how to articulate it just yet, but there is something there. There is something in seeing people, like local, regional people, like forget the cities. They've got their own problems, and their problems are much grander than just this. They're going to have, it's going to be challenging, especially when, large office blocks, suddenly floors get wiped out, departments are gone, when buildings that are call centers, like anybody in a call center right now should be very worried that, like, a lot of the technology already exists. It just hasn't been scaled to an enterprise level. But when does that happen? Like, there are examples of people doing a call center style work with, LLMs. So it's only a matter of time when the cost effectiveness of it is greater than that of a human operator. Because the thing about it, and do you know what? The people will vote for it. The free market will vote for it, because how many times have you made a call to a call center or to a company, and then you're on hold, or you're in the queue and it's like an hour, 2 hours? So if you as a free market think, okay, we've got 2 hours to wait, or it's instant, and you can have a one-to-one conversation instantly. You can have every question answered. It is helpful. It has a broad knowledge base. It can do things at the speed of light. The voice is not only just a dialogue between yourself and a database of knowledge, but it's also the interface and gateway to interacting with all these systems and making the changes that you need for yourself, whether it's changing flights, whether it's updating an insurance product, whether it's making an insurance claim, whatever it may be. These things can, that's why that's in a lot of trouble. And I think it's just waiting for when that graph of cost makes sense. And they work 24/7, so you can have hundreds of thousands of these instances 24/7, no sick leave, no time off work, no interpersonal conflicts, no office dynamics, don't even have to pay them. So anyway, that's that done. So where I want to be is to simplify it, as I just want to be involved in AI, and I want to share the process with the entire world, or anybody who's keen to learn and do things. So with that, I think there's a lot of, like, for what my role is just like pioneering, like scouting out, going out there and seeing all these things and saying, hey, check this out, and just sort of bring all these ideas back to everyday regular people. I think something along that lines. I don't know yet, but hey, I'm going to be here every night and I'm going to give it a go, so we'll see what happens. So yeah, but I don't think I'll go and do marketing. No, I'm not going to go back to my day job, and I'm not going to jump into marketing and commercial design, because it just doesn't serve me, and I don't think it doesn't serve the wider community. It's just noise. It's just adding noise into the universe that, nah. In terms of signal to noise ratio, it's mostly noise. So I might make an exception though. Maybe this vehicle will be where I apply those skills, but no more client work. So let's set in the goal and the attention. This is it. This is the thing that I'm looking to do. Like, I'm just doing it. What it becomes, I don't know. And I guess that's why this is called the creative process. So a lot of this is, just general thoughts and rambling. It feels good to get this out. But anyway, we're going to turn down the AI music and we're going to watch this. I've spoken too much, so let's go.
This is how intelligence is made. A new kind of factory. Generator of tokens. The building blocks of AI. Tokens have opened a new frontier, the first step into an extraordinary world, where endless possibilities are born. Tokens transform words into knowledge and breathe life into images. They turn ideas into videos and help us safely navigate any environment. Tokens teach robots to move like the masters. Inspire new ways to celebrate our victories.
A martini, please.
Only right up.
Thank you, Adam.
And give us peace of mind when we need it most.
Hi, Moroka.
Hi, Anna. It's good to see you again.
Hi, Emma. We're gonna take your blood sample today, okay?
Don't worry. I'm gonna be here the whole time.
They bring meaning to numbers to help us better understand the world around us. Predict the dangers that surround us. And find cures for the threats within us. Tokens can bring our visions to life. And restore what we've lost.
Zachary, I got my voice back, buddy.
They help us move forward. One small step at a time.
That's crazy.
And one giant leap. Together. And here is where it all begins.
A bit of a cheesy opener. I don't like how everything's so Disney-fied.
And CEO,
But
Jensen Huang.
hey, it doesn't matter. It's not the important part. Nice jacket.
Welcome to CES! Are you excited to be in Las Vegas? Do you like my jacket? I thought I'd go the other way from Gary Shapiro. I'm in Las Vegas after all. If this doesn't work out, if all of you object, well, just get used to it. I really think you have to let this sink in. In another hour or so, you're going to feel good about it. Well, welcome to NVIDIA. In fact, you're inside NVIDIA's digital twin. And we're going to take you to NVIDIA. Ladies and gentlemen, welcome to NVIDIA.
It's a bit clunky. But anyway, we're not
You're
judging.
inside our digital twin.
So when we write notes while we do this, just to learn, see what's happening.
Everything here is generated by AI. It has been an extraordinary journey, extraordinary year. And it started in 1993.
Ready, go!
With NV1, we wanted to build computers that can do things that normal computers couldn't. And NV1 made it possible to have a game console in your PC. Our programming architecture was called UDA, missing the letter C until a little while later, but UDA, Unified Device Architecture. And the first developer for UDA and the first application that ever worked on UDA was Sega's Virtua Fighter.
I love this game.
6 years later, we invented, in 1999, the programmable GPU. And it started 20 plus years of incredible advance in this incredible processor called the GPU. It made modern computer graphics possible. And now, 30 years later, Sega's Virtua Fighter is completely cinematic. This is the new Virtua Fighter project that's coming. I just can't wait. Absolutely incredible. 6 years after that, 6 years after 1999, we invented CUDA so that we could explain or express the programmability of our GPUs to a rich set of algorithms that could benefit from it. CUDA initially was difficult to explain, and it took years, in fact. It took approximately 6 years. Somehow, 6 years later or so, 2012, Alex Krizhevsky, Ilya Sutskever, and Jeff Hinton discovered CUDA, used it to process AlexNet, and the rest of it is history. AI has been advancing at an incredible pace since. Started with perception AI. We now can understand images and words and sounds. To generative AI, we can generate images and text and sounds. And now, agentic AI. AIs that can perceive, reason, plan, and act. And then the next phase, some of which we'll talk about tonight, physical AI, 2012. Now, magically, 2018, something happened that was pretty incredible. Google's Transformer was released as BERT, and the world of AI really took off. Transformers, as you know, completely changed the landscape for artificial intelligence. In fact, it completely changed the landscape for computing altogether. We recognized properly that AI was not just a new application with a new business opportunity, but AI, more importantly, machine learning enabled by transformers, was going to fundamentally change how computing works. And today, computing is revolutionized in every single layer, from hand coding, instructions that run on CPUs to create software tools that humans use. We now have machine learning that creates and optimizes neural networks that processes on GPUs and creates artificial intelligence. Every single layer of the technology stack has been completely changed. An incredible transformation in just 12 years. Well, we can now understand information of just about any modality. Surely you've seen text and images and sounds and things like that. But not only can we understand those, we can understand amino acids, we can understand physics. We understand them, we can translate them, and generate them. The applications are just completely endless. In fact, almost any AI application that you see out there, what modality is the input that it learned from? What modality of information did it translate to? And what modality of information is it generating? If you ask these three fundamental questions, just about every single application could be inferred. And so when you see application after applications that are AI-driven, AI-native. At the core of it, this fundamental concept is there. Machine learning has changed how every application is going to be built, how computing will be done, and the possibilities beyond. Well, GPUs, GeForce, in a lot of ways, all of this with AI is the house that GeForce built. GeForce enabled AI to reach the masses. And now, AI is coming home to GeForce. There are so many things that you can't do without AI. Let me show you some of it now.
This stuff's pretty insane. So I guess we got to ask the question, like, what are we actually creating here? So we have these real-time photorealistic rendered worlds. Then we're going to have artificial intelligence. Like, it doesn't seem out of the realm that we're going to be having agents working inside their own simulated world. Like, seeing that face in this environment applied with the intelligence of a sophisticated being interacting,
Was real-time computer graphics.
like, we are going to create the Matrix. We set them to work. Wouldn't that be funny? Like, if agents were, you know, these simulated blocks of people, let's say like an office block, and we give them all jobs and let them do the knowledge crunching, because they don't need to sleep. They don't need to stop. That's insane.
There are two fundamental things that we did. We used, of course, programmable shading and ray trace acceleration to produce incredibly beautiful pixels. But then we have artificial intelligence be conditioned, be controlled by that pixel to generate a whole bunch of other pixels. Not only is it able to generate other pixels spatially, because it's aware of what the color should be, it has been trained on a supercomputer back in NVIDIA, and so the neural network that's running on the GPU can infer and predict the pixels that we did not render. Not only can we do that, it's called DLSS, the latest generation of DLSS also generates beyond frames. It can predict the future, generating 3 additional frames for every frame that we calculate. What you saw, if we just said 4 frames of what you saw, because we're going to render 1 frame and generate 3, if I said 4 frames at full HD, 4K, that's 33 million pixels or so. Out of that 33 million pixels, we computed only 2. It is an absolute miracle that we can computationally using programmable shaders and our ray tracing engine, to compute 2 million pixels and have AI predict all of the other 33. And as a result, we're able to render at incredibly high performance because AI does a lot less computation. It takes, of course, an enormous amount of training to produce that, but once you train it, the generation is extremely efficient.
That's insane.
So this is one of the incredible capabilities of artificial intelligence, and that's why there's so many amazing things that are happening. We used GeForce to enable artificial intelligence, and now artificial intelligence is revolutionizing GeForce. Everyone, today we're announcing our next generation, the RTX Blackwell family. Let's take a look.
I told you 2025 was going to be a crazy year. This is insane. I don't know. Well, it's hard to even wrap a mind around what's going to happen with this stuff. But
here it is. Our brand new GeForce RTX 50 series Blackwell architecture. The GPU is just a beast. 92 billion transistors, 4,000 TOPS, 4 petaflops of AI, 3 times higher than the last generation Ada. And we need all of it to generate those pixels that I showed you. 380 ray tracing teraflops so that we could, for the pixels that we have to compute the most beautiful image you possibly can. And of course, 125 shader teraflops. There's actually a concurrent shader teraflops as well as an integer unit of equal performance. So 2 dual shaders. One is for floating point, one is for integer. G7 memory from Micron. 1.8 terabytes per second, twice the performance of our last generation. And we now have the ability to intermix AI workloads with computer graphics workloads. And one of the amazing things about this generation is the programmable shader is also able to now process neural networks. So the shader is able to carry these neural networks, and as a result, we invented neural texture compression and neural material shading. As a result of that, you get these amazingly beautiful images that are only possible because we use AIs to learn the texture, learn the compression algorithm, and as a result, get extraordinary results. Okay, so this is the brand new RTX Blackwell 5090. Now, even the mechanical design is a miracle. Look at this, it's got 2 fans. This whole graphics card is just one giant fan. You know, so the question is, where's the graphics card? It's literally this big. The voltage regulator design is state-of-the-art, incredible design. The engineering team did a great job. So here it is. Thank you. Okay, so those are the speeds and feeds, so how does it compare? Well, this is RTX 4090. I know many of you have one. I know it. Look, it's $1,599. It is one of the best investments you could possibly make. For $1,599, you bring it home to your $10,000 PC entertainment command center. Isn't that right? Don't tell me that's not true. Don't be ashamed. It's liquid cooled, fancy lights all over it. You lock it when you leave. It's the modern home theater. It makes perfect sense. And now for $1,500 and $1,599, you get to upgrade that and turbocharge the living daylights out of it. Well, now with the Blackwell family, RTX 5070, 4090 performance at $549. Impossible without artificial intelligence. Impossible without the 4 teraops of AI tensor cores. Impossible without the G7 memories. Okay, so 5070, 4090 performance, $549, and here's the whole family. Starting from 5070 all the way up to 5090. 5090, twice the performance of a 4090. Starting, of course, we're producing at very large scale, availability starting January. Well, it is incredible, but we managed to put these in gigantic performance GPUs into a laptop. This is a 5070 laptop. For $1299, this 5070 laptop has a 4090 performance. I think there's one here somewhere. Let me show you this. This is a, look at this thing. Here, there's only so many pockets. Ladies and gentlemen, Janine Paul. So can you imagine? You get this incredible graphics card here, Blackwell. We're going to shrink it and put it in there. Does that make any sense? Well, you can't do that without artificial intelligence. And the reason for that is because we're generating most of the pixels using our tensor cores. So we ray trace only the pixels we need, and we generate using artificial intelligence all of the other pixels we have. As a result, the energy efficiency is just off the charts. The future of computer graphics is neural rendering, the fusion of artificial intelligence and computer graphics. And what's really amazing is, oh, here we go. Thank you. This is a surprisingly kinetic keynote. And what's really amazing is the family of GPUs we're going to put in here. And so the 5090 will fit into a laptop, a thin laptop. That last laptop was 14.9 millimeters. You got a 5080, 5070 Ti, and 5070. Okay, so ladies and gentlemen, the RTX Blackwell family. Well, GeForce brought AI to the world, democratized AI. Now AI has come back and revolutionized GeForce. Let's talk about artificial intelligence. Let's go to somewhere else at NVIDIA. This is literally our office. This is literally NVIDIA's headquarters. Okay, so let's talk about AI. The industry is chasing and racing to scale artificial intelligence. And the scaling law is a powerful model. It's an empirical law that has been observed and demonstrated by researchers and industry over several generations. And the scaling law says that the more data you have, the training data that you have, the larger model that you have, and the more compute that you apply to it, therefore, the more effective or the more capable your model will become. And so the scaling law continues. What's really amazing is that now we're moving towards, of course, and the internet is producing about twice the amount of data every single year as it did last year. I think in the next couple of years, humanity will produce more data than all of humanity has ever produced since the beginning. And so we're still producing a gigantic amount of data, and it's becoming multimodal. Video and images and sound, all of that data could be used to train the fundamental knowledge, the foundational knowledge of an AI. But there are, in fact, two other scaling laws that has now emerged. And it's somewhat intuitive. The second scaling law is post-training scaling law. Post-training scaling law uses techniques like reinforcement learning, human feedback. Basically, the AI produces and generates answers based on a human query. The human then, of course, gives a feedback. It's much more complicated than that, but that reinforcement learning system with a fair number of very high-quality prompts causes the AI to refine its skills. It could fine-tune its skills for particular domains. It could be better at solving math problems, better at reasoning, so on and so forth. And so it's essentially like having a mentor or having a coach give you feedback after you're done going to school. And so you get tests, you get feedback, you improve yourself. We also have reinforcement learning AI feedback, and we have synthetic data generation. These techniques are rather akin to, if you will, self-practice. You know the answer to a particular problem, and you continue to try it until you get it right. And so an AI could be presented with a very complicated and a difficult problem that is verifiable functionally, and it has an answer that we understand, maybe proving a theorem, maybe solving a geometry problem. And so these problems would cause the AI to produce answers, and using reinforcement learning, you would learn how to improve itself. That's called post-training. Post-training requires an enormous amount of computation, but the end result produces incredible models. We now have a third scaling law, and this third scaling law has to do with what's called test time scaling. Test time scaling is basically when you're being used. When you're using the AI has the ability to now apply a different resource allocation. Instead of improving its parameters, now it's focused on deciding how much computation to use to produce the answers it wants to produce. Reasoning is a way of thinking about this. Long thinking is a way to think about this. Instead of a direct inference or one-shot answer, you might reason about it. You might break down the problem into multiple steps. You might generate multiple ideas and evaluate, your AI system would evaluate which one of the ideas that you generated was the best one. Maybe it solves the problem step by step, so on and so forth. And so now test time scaling has proven to be incredibly effective. You're watching this sequence of technology and all of these scaling laws emerge as we see incredible achievements from ChatGPT to O1 to O3, and now Gemini Pro. All of these systems are going through this journey step by step by step of pre-training to post-training to test time scaling. Well, the amount of computation that we need, of course, is incredible. And we would like, in fact, that society has the ability to scale the amount of computation to produce more and more novel and better intelligence. Intelligence, of course, is the most valuable asset that we have, and it can be applied to solve a lot of very challenging problems. And so, scaling law. It's driving enormous demand for NVIDIA computing. It's driving an enormous demand for this incredible chip we call Blackwell. Let's take a look at Blackwell. Well, Blackwell is in full production. It is incredible what it looks like. So first of all, there's some, every single cloud service provider now have systems up and running. We have systems here from about 15 computer makers. It's being made about 200 different SKUs, 200 different configurations. They're liquid-cooled, air-cooled, x86, NVIDIA Grace CPU versions, NVLink 36 by 2, NVLink 72 by 1, whole bunch of different types of systems so that we can accommodate just about every single data center in the world. Well, these systems are being currently manufactured in some 45 factories. It tells you how pervasive artificial intelligence is and how much the industry is jumping onto artificial intelligence in this new computing model. Well, the reason why we're driving it so hard is because we need a lot more computation. And it's very clear that Janine? It's hard to tell. You don't ever want to reach your hands into a dark place. Hang on a second. Is this a good idea? All right. Wait for it. Wait for it. I thought I was worthy. Apparently, Yonir didn't think I was worthy. All right. This is my show and tell. This is a show and tell. So, this NVLink system, this right here, this NVLink system, this is GB200 NVLink 72. It is 1.5 tons, 600,000 parts, approximately equal to 20 cars, 120 kilowatts. It has a spine behind it that connects all of these GPU together, 2 miles of copper cable, 5,000 cables. This is being manufactured in 45 factories around the world. We build them, we liquid cool them, we test them, we disassemble them, ship them in parts to the data centers because it's 1.5 tons. We reassemble it outside the data centers and install them. The manufacturing is insane. But the goal of all of this is because the scaling laws are driving computing so hard that this level of computation, Blackwell over our last generation, improves the performance per watt by a factor of 4. Performance per watt by a factor of 4, performance per dollar by a factor of 3. That basically says that in one generation, we reduce the cost of training these models by a factor of 3. Or if you want to increase the size of your model by a factor of 3, it's about the same cost. But the important thing is this. These are generating tokens that are being used by all of us when we use ChatGPT or when we use Gemini, use our phones in the future. Just about all of these applications are going to be consuming these AI tokens. And these AI tokens are being generated by these systems. And every single data center is limited by power. And so if the perf per watt of Blackwell is 4 times our last generation, then the revenue that could be generated, the amount of business that can be generated in the data center is increased by a factor of 4. And so these AI factory systems really are factories today. Now the goal of all of this is so that we can create one giant chip. The amount of computation we need is really quite incredible. And this is basically one giant chip. If we would have had to build a chip, here we go. Sorry, guys. You see that? That's cool. Look at that, disco lights in here. If we had to build this as one chip, obviously this would be the size of the wafer, but this doesn't include the impact of yield. It would have to be probably 3 or 4 times this size. But what we basically have here is 72 Blackwell GPUs or 144 dies. This one chip here is 1.4 exaflops. The world's largest supercomputer, fastest supercomputer, only recently, this entire room supercomputer only recently achieved an exaflop plus. This is 1.4 exaflops of AI floating point performance. It has 14 terabytes of memory, but here's the amazing thing. The memory bandwidth is 1.2 petabytes per second. That's basically the entire internet traffic that's happening right now. The entire world's internet traffic is being processed across these chips, okay? And we have 130 trillion transistors in total, 2,592 CPU cores, whole bunch of networking. And so these, I wish I could do this. I don't think I will. So these are the Blackwells. These are our ConnectX networking chips. These are the NVLink. And we're trying to pretend about the NVLink spine, but that's not possible, okay? And these are all of the HBM memories, 14 terabytes of HBM memory. This is what we're trying to do, and this is the miracle of the Blackwell system. The Blackwell dies right here. It is the largest single chip the world's ever made. But yet, the miracle is really, in addition to that, this is the Grace Blackwell system. Well, the goal of all of this, of course, is so that we can, thank you, thanks. Boy, is there a chair I could sit down for a second? Can I have a Michelob Ultra? How is it possible that we're in the Michelob Ultra Stadium? It's like coming to NVIDIA and we don't have a GPU for you. So we need an enormous amount of computation because we want to train larger and larger models. And these inferences used to be one inference, but in the future, the AI is going to be talking to itself. It's going to be thinking. It's going to be internally reflecting,
I think we're going to
processing.
stop it there.
So today, when the tokens are being
Hey,
created
wow.
at you, so long as it's coming out at...
We've got the AI music in the background. So, man, that's fascinating. There's a lot to take in there. And as I said, like, listen to the platformers, like these platform companies. It really does point to where the zeitgeist is heading towards. So, yeah. So some of the notes I got from that, it's sort of in, with this stuff, we sort of try and predict what does this mean for regular people. It's great to say that AI is here and self-driving cars and robots, but what does this actually mean day to day? And I think that's going to be the challenge. And so some of the notes I've got from that, that short thing, and it's still going now, but I'll probably watch the rest of it another time, is it seems like simulation AI is going to be the thing. Simulation. We talk about the Matrix and in looking at the, the real-time rendering, and you've got these intelligent agents interoperating. This sounds all cool, and this makes for it makes for a great headline, a great news story. But what does it actually mean for us day to day? What is the utility of this? And these are the important moments, and this is like with this creative process in staying up late to sort of pontificate about this stuff is like, yeah, these are all cool fantasies, but what can we actually do with it? Like the idea of having, these agents, you have your own block essentially of, I don't want to call them agents. I think that's a bit disingenuous, but I'll just say like a simulation of people. And you put them in this box, in this container. You set the environment variables of, you're all these different personalities and personas. Now I want you to go out there, or I want you in this room. I want you all to discuss this problem until you come to a consensus. Then you press play and set it to go, and then it does it. Now that doesn't sound that far-fetched because I've actually done this. I've done this using ChatGPT. So in previous sessions when I've spoken about creating this AI system, just using the ChatGPT API or the OpenAI API, is I managed to create essentially like a round table that had different personas around this table. Now each persona had their own perspective, their own values, their own way of seeing the world and understanding it, and they're all different from each other. And then what I would do is then I would put a topic in the middle, and I would make them have a formal debate over it. And what was really interesting, because this was in the very first days of like ChatGPT, where like this stuff wasn't thought of, this stuff wasn't necessarily possible, but it was actually really simple to do. But the fascinating part and the powerful part was, because I had never seen this before, like ChatGPT had been out for maybe 4 weeks at that point. I know, GPT had been around for at least a year before that. publicly. And when I pressed play, essentially on it, and I put a topic in, it was amazing, like just to see the AI respond to itself. And what I really liked about it is that as it replied to itself, different instances of itself, like different personas, the answers would evolve. So as it was going down, the answers would evolve because it would state a point. And I think, I threw, like, let's say, a Trump thing, and then they had all their perspectives on that. But then when it would bounce a counterpoint off that, the answers just evolved. And then what I would do is that, I set the rules that you have you just keep going to have a consensus. So how do you achieve that? How do you achieve a consensus? Well, it turns out that it's already been solved. A lot of these AI systems, I don't think you necessarily have to, come up with these fancy formulas, especially, at the level that I'm talking about. You don't have to come up with these fancy formulas and get all mathematical about it. It was looking at what already exists, what system already exists, and how do I replicate a version of that, and then how do I build upon that and refine it. So for this debating system, this self-debating system, I got, what did I do? Oh yeah, I just copied the debate structure of what a formal debate was. Where there were opening statements, there would be, I can't remember, this was a couple of years ago I did this, and then I would have a moderator. So the moderator was good because they sort of were the objective part of this that moved the conversation forward, so things didn't get stuck in these loops. And it was a really interesting experiment. And I'm actually thinking that, like, when I came out with this, I had the big exhibition. It was fascinating. And in previous streams, I went into that. I'm not going to go into that in these streams, but when I do the weekly show, we'll have one coming up this week. I'll probably do just a YouTube video about this, because it's a fascinating thing. But at the time, no one understood it. People thought I was crazy. My in-laws, they're sort of like looking at me like, what the fuck are you doing? My missus, she was excited in theory, and by that I mean like the premise of creating an AI that argues with itself until it reaches a consensus. That's a really fascinating concept. Philosophically, sorry, it's getting quite late. My words are blurring, but it was a really interesting sort of a question you're putting out there into the world. And I was speaking to someone this year about it, because I've been running courses and so on, and I was speaking to one of the students who's getting into this AI stuff, not AI development, but more AI at the prompt engineering level, which I think there's a lot of value to that. I think that's something people are sleeping on, sort of undervalued, because you're not necessarily, the creative force as such. You're just the person typing the text. But he said, I was telling him about it, and then I ran a version for him, and his mind was blown. He said, why don't you keep doing this? And I said, well, everyone kind of hated it. And as I spoke about in the session earlier in the week, it was that, I got this to debate something very important in politics in Australia, something that was going to affect the Constitution, and we all had to vote on it. And I thought, great, I'm going to put this system on display. I'm going to mimic the voices of the Prime Minister and the opposition leader. Prime Minister is like the president. And then I'm going to have them debate this topic, ta-da. while, you know, the country, like, it was mandatory. We all had to vote on it like a week later. So I thought, how poignant is this? Here's this big topic that we have to, every voting age Australian has to do it. It's very divisive. It's split the country down the middle. And I'm going to have AI perform this. And I did it. I had the mimic the voices. It's a very visceral setup, and I will put this into the YouTube video. But it had like one screen at the fore and one screen on the other side as against, and you know, a big setup. And then it would just play back and forth like a tennis match, and it was wonderful. Like, I loved it. I don't think people quite got it. Like, here's the funny part. The way I designed it is I wanted the technology to step out of the way. You know, I didn't want, I didn't want people to be talking about the design. I didn't want the font choice sticking in the way. I didn't want the colors sticking in the way. I wanted it to be very deliberate and have a very understated, very minimalist, like, still good, visceral, so you could see, you know, for and against, something that a child can look at. They may not understand the topic, but they can see, okay, well, that's for, that's against, and that's the topic, and they're talking backwards and forwards, and it's a setup. And yeah, so people would come in, like old people would come in, and they would just talk about the topic. Actually, everybody just spoke about the topic, and no one really looked at the system itself. No one sort of questioned, like, the elephant in the room was, here was someone with no experience in coding, no experience in developing, no experience in AI, built something on my dining room table, and, you know, just put it out there into the world, having this, like, very logical and rational debate, mimicking the country, the leaders of the country, and arriving to a very, you know, considered conclusion and consensus. And no one even kind of, no one even just, that was the thing. It's like, hey, here's someone who doesn't know what they're doing. They built this thing, and I used AI, I used ChatGPT to help me make this, because again, I don't have a development background, and no one sort of like looked at that. It's like, holy shit, this thing is really a really powerful tool. So, and then I got kicked out of the exhibition. That's another story, but I spoke about that earlier in the week. But yeah, got kicked out because it offended the event organisers. They had their beliefs, and they weren't even offended by the fact that I've used AI or ripped off the country's leaders. They were offended because they took a stance as I think they were for, and they said that I didn't have any right to do this because it's not my place to have a say. Even though the following week, I, like myself, everybody else over 18, had to vote on it. So anyway, long story. And I've done this before. So I've also done this with ChatGPT, with clients. So I did this with a client. So that they started they're looking to start a new business, and their business isn't like a wellness one around like saunas, like a day spa with saunas and cold plunge, things like that. But they were going to put it in a really beautiful area, and it was going to be like a semi-outdoors. So you'd be sitting in these saunas and so on, but you'd be outside in this really picturesque view. And so they weren't sure if this type of idea was going to work in this market. And so I sort of went back to my laptop and I thought, you know, wouldn't it be cool if you could simulate it? And so what I mean by simulating, I thought, wouldn't it be cool if you could play it out and see how it happened? So here's a better way to explain it. I took the business plan of what they had, took the products that they're going to use, had like the pricing structure, and I put that into a document, and I put that into ChatGPT. Then I sort of picked a segment of the market. And so this is not exactly it, but this is just as an example. And the market is Australia. And so I picked a segment of the market that was like 25-year-old female that likes this, this, and this, and this. Her partner is male. He likes this. He's, a builder, watches football, blah, 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 blah. Fill in your own backstories. And then I said, basically, here is a couple. I want you to write a scene, just like a TV scene or a movie scene. I want you to write the script and the dialogue for this couple, figuring out whether they want to, or evaluating whether they want to go to this place or not. And so I did it, press, essentially enter or play, and it worked. Like what would happen was crazy, because it has to think. Once you set the variables, it has to sort of think. So it took that market and it worked out that, okay, these people in this scene, they're going to be a couple on the couch. They're going to be sort of semi-watching TV while one person's cooking, and they're going to have this dialogue play out. And so as I read through the script that it came up with in the scene, what they were debating over, I also, in their persona profiles, I put in how much they earn per year, hobbies, just sort of lifestyle factors. I like a persona profile. So what their wage was and so on. So that was sort of helped to frame their choices and also their personality types. So it was pretty extensive, but short. Like it wasn't pages and pages. And as this scene played out, it was very revealing, because what they were debating on is the price, because the client, in this case, had a high price point. And so what they sort of came to the conclusion in that particular scene is they said, well, it's quite expensive, relative to what they were earning. It's like, well, maybe we can try it once and see if we like it. And maybe we should make it more of a date day. So instead of a date night where you go out, have some drinks and dinner, it was like a day date where, they would go there in the morning, they'd have coffee, they'd feel better, sort of invigorated. And then if they liked it, they might consider doing that once a month. And that was just a scene. And there's more detail in that, but what was really fascinating was that he's just sort of there, sort of witnessing and viewing that. It's like, okay, that's a really interesting scenario that's simulated. Again, this is not real data. It's a type of real data in the sense that it's been pulled from a vast knowledge base that is ChatGPT and everything that's been trained on. But it's not real data in the sense we haven't asked people in this particular area. We put a lot of assumptions in there. So that played out, and then we came up with the idea, okay, well, maybe with our pricing structure, maybe we give people like a discount, introductory offer for like a couples. So instead of having like, let's just say, I can't remember the price, but let's just say one person's $45 for an hour. Instead of like two people, $90, it might have been discounted at like two people for $70 or something. And what that was to do is to use pricing and sort of this offer to encourage couples to go, or friends, people who have a bond and paired, that they can go through and make more of an event out of it, make it more of a monthly ritual. And so that was a really interesting, like the company hasn't opened yet, but that was just a really interesting example of this idea of this simulation. So yeah. Some other notes. So I think this is all possible, and it's going to be really interesting, the form factor of where this ends up, because yeah, you can already do this in ChatGPT, but it doesn't necessarily have the layers, the quantifiable layers. you know, this is all just like clever prompt engineering, creative prompt engineering. But there needs to be more dials and switches, or maybe there doesn't, that we can make this more actionable or more accessible. Because from the from the conclusion of that couple in that dialogue, then what you can do is you can use that as a ground truth or a source of information to then sort of feed out like more content. From that, you could say, we'll write a marketing campaign around this scene. So he takes this understanding of these characters, these personas, and now it shapes something like that. So I think that's fascinating. I think, when we talk about, this year is going to be about the agents, then I think these are fascinating things. So that's a good way for like product testing, but what is the greater value beyond just these like simple things? And I think this is the $1 million question. Another like really important thing that you raised was like just the line, impossible without artificial. Sorry, it's late. Impossible without artificial intelligence. So that's a really interesting one to think about. Impossible without artificial intelligence. I'm just having a quick browse. Okay. Possibly that artificial intelligence. That's a good way to frame things, because a lot of the stuff that's happening now, it's just like shit marketing, shit social post, just lame stuff. And it's like, it's great that we can replace copywriters. Well, it's not, but it is what it is, or designers. But in looking at like what Midjourney is, like it's fine, but what are we actually achieving with Midjourney? Yes, we can create all these images like really fast, and we can do whatever we want, but like, what are we actually doing here? Like, are our designs better? I don't think so. It looks like Behance. Is it like moving the culture forward? Maybe. I think there might be some very clever people out there who are doing something interesting with it. But like, what are we actually doing? And so when you go back to Jensen's quote from that video, which is impossible without artificial intelligence, that's an interesting way to frame things. It's like looking at well, I think it's important to not sort of be a solution looking for a problem, but I think it's helpful to frame, well, nothing else can solve this. I don't know. I don't want to jinx it and try to frame something. But again, like, this is why this is called the creative process, because there are no answers as such. There is just a process. And along that process, that creative timeline, there are just milestones where, key significant things have happened or been delivered. But in terms of having an answer, I don't believe there's an answer. We just arrive at a point which helps us to then set up and begin for the next stage. Another thing was interesting. I've got a note here that says neural rendering. So that's really interesting, where this system is inferring what things look like. And he had a really good point about it sees the future. It's like rendering, I think, 3 frames into the future. That's really interesting. Is well, again, that's such a big thing to think about and talk about. Neural rendering. I'm actually going to add that to it. Oh, by the way, I'm going to have I've got a new camera stand coming, so I'm going to have a camera up top so you can see me write the notes, because this whole thing is about the process of taking all this information and creating something from it. Like, this is not about, you know, tuning in and, you know, there's an answer. Like I said before, there are no answers. There is just the process. Because how do you know when you're at the answer? But yeah, when I get the camera set up, you can see what I'm writing there. Okay. Yeah, another note I had was reasoning. And I think this goes back to the debating system I was talking about earlier. Yeah, how it reasons. The structure of reasoning. And I will share how my system reasoned. It was actually pretty novel and very, very simple. But I actually used ChatGPT in conjunction to help put it together. You know, I had the basic framework of what I wanted. Then I said, you know, take this and help me like flesh it out. And then it had suggestions. Then I took those suggestions, sort of put it back into my model, sort of looked at it from a different angle, and I thought, chucked it back in there. And it was like this really sort of symbiotic computer human loop of creation. Oh, here's the other thing that just came to mind. The most and this is a thing that no one, it still blows my mind. It's like, how did I find this so fascinating and no one else found this fascinating? I went up on stage in you know, different states around Australia, big cities, big conferences, and people kind of like wowed, but not. It's the weirdest type of thing I've ever seen. So I created this system that just, you know, debates any topic from all different angles until it comes to a consensus. So I thought, how meta is this? I'm going to put the topic of this system I've created into the debating system as a topic. So it would debate over the concept of itself. Now that sounds pretty meta, and it was very meta, but here's the fascinating part. So it argued back and forth from all these different angles. And one of the things that it came out with, I need to pull up these transcripts, and I actually need to rebuild this and do it again. But one of the things it came up with, it said this system will never work. And I can't remember why. It had a reason why it would never work. I can't remember if it was related to cost or if it was related to people not accepting it, because it sort of puts to question human reasoning and something. It sort of questioned whether humans were at the top of this decision-making tree or not. But the general consensus was, it said it would never work for whatever reason, and I will find what that reason was. And oh no, I think it was something along the lines of it would never work because something like businesses won't be able to implement this thing, or something like that effect. And I remember being up on stage and I was saying, the fact that this system is saying that it doesn't work, it's not going to be suitable for anybody, is proof that it works. It's like, let me just say that again and really get it out there. The system debated over itself as a topic, and it came to the consensus that it would never work for whatever reason it may have been, whether it's a social license or when people accepting it, people just not understand it. And it didn't work. And like, it didn't like, it didn't have any traction. It didn't, wasn't accepted. But the fact that the system came to the conclusion that it wouldn't work is proof that the system worked. And so that just blew my mind when I saw that, which didn't help me because I was running the idea of this system into it to try and help me make it better. But yeah, it didn't work. Ultimately, it just didn't have the traction. I don't understand. Like, it was never built for a business case in mind. It was just built to see what would happen. So maybe this system was called Rage, by the way, because I thought that would be funny. I actually called it Rage with the machine. That was my URL. But I think this train of thought is probably important because that's what's coming down the tube. Other things he said, or this is what I said, never sleeps. Like, these systems never sleep. He said coach, mentor, and feedback on performance. So that's a really interesting one, and that's one I've been exploring a lot lately. I'll go into more of that, I think, tomorrow. But I think for tonight, well, we're going to leave it there. It's 12:30. I gotta get some sleep. Ready for a big family day. So thank you for tuning in. Hope you've enjoyed this AI music. Hey, 2025 is going to be an incredible year, and this year may change everything. By these predictions of these experts and these big companies, there may be no other year like 2025. And for us as the little guy, we can either make the choice to just be caught up in the whirlwind, or we can build something. And I think us as the people who are going to be, our jobs are going to be in question. Like, we're the ones who need to figure this out. Otherwise, we're just going to be I don't think we'll be advantaged. I don't think these systems have been designed with our best interest in mind. Because we could say, well, look at social media. Like, look at that. Like, that wasn't... Sure, it started as that utopian view of everybody connected. But what did it actually turn out being? It turned us into raging battery hens, factory farmed for our attention, convert that to ad dollars that, with all our data stolen, well, not stolen because we are complicit to it, we did sign up to use these things. And what has been the final product of that been? Well, there's ultra wealth happening now. And while we're not getting any of it, ultra wealth, to which we're not getting, and now everybody hates everybody. So I think these systems that sound good at the surface, I think there's market incentivizations that lead it to certain paths, which ultimately means that they feed upon us, the regular small people across the world, and our lives, our experiences degrade. Companies, entities, and founders proliferate. They sort of get held up as these demigods, these untouchables, and we're sort of they've hijacked our experiences and then sold it back to us like these are these deities, these gods that should be worshipped. But if we sort of take a step back, is that they've diminished our quality of life. and they've done very well off it. So, and I'm not here complaining about social media because there's a lot of fantastic things to it as well. But what I'm sort of using that as a point to illustrate is that AI, and let's say it goes down the agent route, it's not going to be any different. Sure that we're going to get these tools that provide great value at first, and they're probably well intended. But it doesn't mean that the same market forces that turn social media down the path that it's led us to, and this is not anecdotal, this is not my speculation. You just look around. You see doom scrolling everywhere. Like, people just cannot stop. Walk in, I spend a lot of time in the playground with my kids, and you look at the parents. They can't stop scrolling on their phones. They can't be with their kids unless something's actually happening. And some of the parents who are more active, they're absolutely there, but a lot of them are lost. So going down this AI route, I don't think it's going to be different, because this is just a system we're in. This is just human. I think capitalism is just the personification of human behavior. Well, it's not personification, it's a manifestation of human behavior in the free market. And I think we really have to start having this conversation now. Not just me, not just whoever's listening, but everybody needs to sort of, really have to cement our values now. Otherwise, we're going to end up like that. Maybe the Matrix is real. But anyway, that's enough for me tonight. We'll be back tomorrow. We'll do another session, the creative process, and we're going to figure this out. We're going to figure out what direction we're going to be heading this year, down the AI simulation / reasoning. It's going to be a big year. So stay tuned. Thank you, and enjoy this AI song. Bye.
I'm Nikola Tesla, master of lightning, electric successor, wireless who dreamed of a better tomorrow. Inventor, futurist, idealist, liberated in my time, but liberated in my time, but